Hello and welcome to 31st lecture of the course on corrosion, environmental degradation and surface engineering. Topic of the present lecture is economic losses by corrosion degradation. So, we are going to discuss about losses which caused by corrosion degradation, and the whole course we have been given more emphasis that degradation or surface degradation should be minimized as possible to almost negligible level. So, let us start with this lecture, and then what we are trying to understand, is it possible to come to the zero? Can I really eliminate complete corrosion? So, for that purpose we say that from where the materials come, mostly we mine. Of course, we can do a synthesis of the material in the lab also, but most of the materials we get from a nature, and then we need to mine it. And when you do mining, the most of the time materials have some sort of oxide formation. Let us take an example of iron oxides. Then you need to convert in a much more meaningful way, or maybe increase the purity, then a number of mills, number of operations. But in every case, what we do, we keep adding the energy in this. So, what material we extract that has a minimum energy, and we keep adding energy to make as a product. Like in this case, what I will be shown something like underground pipe, while in this case we are showing automobile body. In both the cases, the steel is been utilized. Of course, the polymers are also been utilized in these days, but we are just taking example of iron. And finally, what will happen, corrosion, or because of the corrosion they get rusted, and those rust are maybe discarded one way or another way. So, this is the final form, rust is the final form, initial is also oxide form. So, wherever material started, finally it is going and landing in the similar manner. So, can we really prevent it? Now, question comes of prevention, the absolute we can use a word, yeah, it is not possible. Complete prevention is unavoidable, or maybe say we can't really avoid the surface degradation due to corrosion to almost zero level, it is not possible. However, we can delay, we can enhance the working life, service life to a greater extent. Now, why we are saying this one? Because we know that the system's Gibbs energy is basically driving force behind all the corrosion process. If Gibbs energy is on higher side, or that there is a high energy, the possibility of corrosion will enhance significantly. And that is why we can say no, corrosion cannot be avoided, but it can be lingered, can be postponed to some maybe say instead of 5 years takes 10 years, 15 years or something like that. Those are possible. So, if I want to reframe what I said, say in order to produce metals or any engineering component, we keep adding energy to the system. Consequently, metals have entire, obviously the very high desire to return back to the natural state. That is what everybody feels that way. If we have a lot of energy, finally we need to take a rest, and the material also will have a lot of tendency to come back to the lower state, low energy oxide state. That's a reason for the corrosion. We can, as I say, that we can linger, or we can increase service life by utilizing effective corrosion management technologies, by hindering the path of the equilibrium which material wants. In we have in this complete course, what we have learned, that production of natural surface oxide layer, when you really finish any material, particularly the ferrous material, we will find some sort of oxide layer on the top of that, even in the case of the aluminum also. And these oxide layers are typically of thickness of the 10 nanometer. So, it is not a huge thickness, or they are not thicker with 10 nanometer thickness. And we know because of this sacrificial layer thickness, materials can be utilized. In the virgin state, we cannot utilize those material. but because of that oxide layer, and we are able to utilize most of the ferrous material and aluminum materials. So, this is very important to understand. And then we have learned a number of mechanisms. So, we can say understanding corrosion and utilizing a data driven approach, because I mentioned very clearly that there are many processes involved in an atmosphere, and corrosion will happen one way or another way because of the different mechanisms. So, doing accurate modeling while in advance will be very difficult, and that is why we really require data capturing, or maybe the online or maybe in situ data capturing and then processing those data, so that the protective coating can be formed, or even there is a protective coating, if there is some sort of flaw or maybe some sort of fault in that can be diagnosed well in advance. Based on that, we can really keep on changing the material, improving the working condition, so the corrosion resistance enhance. And then we also learn something like a surface treatment can be done to enhance the working life of the component. In addition, we learn that a coating are frequently employed. I can say it is like a first line of defense against the corrosion. So, whatever the coating we use, it is the first line of defense against the corrosion, which whether we are using automobile, we are using aircraft, whichever the situations, and that is where it is important for us to learn even the coating. And in previous lecture, we also learn how to select the best coating based on the features which we understand. Now, what we can say that what we have learned as such corrosion, we say there are basically two electrochemical reaction, one happens at the anode, other happens at the cathode. Now, if you want to really delay this kind of actions or reactions, so then what we do, we use some sort of inhibitors, and this maybe it nitride or maybe the phosphate or maybe some sort of organic compounds, they are added to the electrolyte in order to slow down the corrosion process, whether it is anodic process or the cathodic process. So, we try to delay using our engineering knowledge, and then as I mentioned that maybe we do not have a sufficient knowledge, we start and then we have some sort of sensors, and we have extensively and then the covered non-destructive testing. So, we can figure out what are the faults which are really emerging in a system, and then we can take a number of preventive actions. So, we can delay corrosion, but we cannot eliminate the corrosion, and there the data driven approach becomes now very important to understand and apply. And when we are talking about the data driven approach, I am just trying to pick up my earlier slide where we have mentioned about this. There is a CM or maybe say condition monitoring, in situ condition monitoring should be done, and then there should be data acquisition. We need to have a sensor which requires to acquire the data. Those data need to be processed, and after doing a processing, then we need to be we need to figure out whether there is some sort of fault, and some sort of processing has to be done. In addition, we say that prognostic approach should be adopted, where the maintenance strategy also can be utilized in a better manner, and then what we are planning that we can enhance a useful life of the product. So, question comes, can we really do without data driven approach? No, it is not. What is the really reason? Because there are number of industrial and manufacturing processes where there are number of degradation, and then they are not revealed immediately. That is why we require non-destructive approaches. So, things which are not visible to us, and then whatever you do estimation of the life or estimation of the failure time, that may not be correct, and that is why we really require data driven approach. So, whatever we calculate theoretical, and then that model need to be refined again and again by iterative methods. So, this is very important to understand. Another thing is comes to that what is the relation between the condition based monitoring, degradation process, which we are trying to model one way or another way, acquire data to estimate the residual useful life, and then finally comes economics. and in present lecture we are going to focus on only on economics, whether this is really connected with the other things or not. And that is what we really require in this case to enable to understand the failure behavior, enable another or consider or take a very good decision or better decision when we have this correlation available, condition monitoring based, degradation and the process modeling based, or data driven, residual useful life, and finally economics. If we are able to connect these 4-5 streams, then overall the results will be more favorable, and that is what we are going to cover in the present lecture. Let us start from the first thing, that what we are trying to focus on the corrosion or effect of the corrosion. Now, why the corrosion really happen, and why as I mentioned we are not able to eliminate. Now, what is the really reason? We say that there is a close proximity of the water or humidity. Water is essential for human life, and then we know that our environment has a humidity. So, these are the important part of the society as such, and then we have mostly the metals environment, or maybe the different places including building or maybe artifact, and those things are there. Earlier we were thinking that only the metal gets corroded, but now we have a research, and the research finding which indicates also the ceramics also get corroded, polymers also get corroded, composites also get corroded. So, almost all the materials get corroded over the time. So, this is important, and then there are number of research articles which indicate, there are what I mentioned here, the numerous research studies have quantified substantial financial losses. It is very important for us to understand that when there are substantial financial losses related to the corrosion, and it has happened because of the corrosion, material degradation happens much faster. One end we are trying that we should enhance the service life of the systems by delaying, by minimizing the rate of the corrosion, and we know that because of the corrosion, the otherwise the wear itself was not sufficient to accelerate the wear damage, but because of corrosion or assisted corrosion, then the degradation will be much faster. And then to the tune of what the study says, there are losses of financial losses in the tune around 3% of GDP. Of course, in India, one of the figure I last time given maybe say first or second lecture, the 5.95% of the GDP. This was a huge number. While we are saying that for the developed countries like USA, that this number is around 3% of their GDP. Now, we can analyze that why this is happening, why in our case 5.95 and why in this case is something like a 3%. But whatever this number, even the 3% what we are indicating for the USA, and this report says that in the United States, the corrosion is projected to incur the cost roughly $2 trillion to $4 trillion per decade. That means 0.2 trillion to 0.4 trillion per year. So, this is the cost of financial losses because of the corrosion, and then they have a given comparison that whatever this expense which is happening in a 10 the years, which is this is equivalent to the expenses which happened because of the natural calamity, or the big the loss to the society, and then they have a given something like Katrina, which happened in 2005, of the tune of that. That's such a huge loss, and there's a happening, or maybe the natural calamity happens once in a while this kind of corrosion happens in every year. So, we should pay the more attention. We should look at the financial then the implications or the losses which are happening because of the corrosion. So, there is one report from National Research Council. I just changed the color of my the pen. This is the and the National Research Council, they publish and then the report in 2011. And then what has been mentioned here, what are the impact of the corrosion. So, whole focus was the impact of the corrosion. They say it also affects national security and the readiness. It's something like army has a number of tanks, or maybe the devices to launch some sort of bombs also. But if those get corroded, what will happen? There will be huge loss, even that when you want to operate that machine, it will not get operated. So, this is one of the major issue. Even now, suppose we have implants in a body and they get corroded, because there are number of fluids in a body also, a possibility of corrosion. So, naturally health and safety will become a major issue in that case. Now, coming to the energy and fuel, we know there are pipelines, and pipelines get corroded also, and if a gas gets leaked into an environment, again there is an issue. If the fuel gets leaked, then there is a direct loss and indirect loss also. And we have learned in Bhopal tragedy case also, that causes a major problem. Another one, as a natural treasures or artifacts which has been shown in something like this, they also get affected. You keep polishing, what will happen? Finally, things will not be in the shape. Maybe the natural color or natural beauty will go away. So, this is another one. Another the major loss which an NRC says is something like a productivity. What is the meaning of that? So, there is some sort of overhauling of the bridge. And then what will happen, they will close the road for the maybe say 7 days, 10 days, 1 month time also, and the person who is really used to go and cross only 1 kilometer, required only to bridge a gap of the 1 kilometer, need to go really around 5 kilometers, 7 kilometers. So, time will go in a much higher side. Another thing is that because of that, there will be loss of the productivity. So, that loss is also important. We already have covered in our course in detail about infrastructure and engineering devices, including the ships, including the aeroplanes, those case studies. And of course, whatever happens, whatever the degradation, it is released back to the environment, and the environments get polluted. So, this report is a very good report, indicates that there is a lot of research or there is a lot of need to do research in a corrosion science and engineering, so that we get a better results. If I want to express these things in slightly different manner, we can say the National Research Council expressed the need of corrosion education. Reason being that many people who even do a corrosion research, they will be focusing only on one type of corrosion, or only maybe say the very small element. But the need to really educate society about this kind of faults or this kind of financial losses is very important. That is why I say that NRC expressed the need of the corrosion education to build national abilities to respond to the emergency and the situation related to even the national securities. So, those things are important, and we say that even the cost which we have been getting into the tabular form number of times, those costs are basically how to maintain the system, how to replace the system, and then these are the direct costs. But what will be the cost related to the even military case, if there is a response is longer one and we are not able to immediately react whatever the attack happens, so and that who will be at the cost. So, naturally society has to be at the cost. So, this even the military delay will be costing to a nation a bigger way. That need to be understood. And another one like a bridge, as I mentioned, maybe they go for there is some sort of breakage of the bridge, and then overhauling is being done, or maybe we will say that some maintenance work, or maybe some portion which has got damaged is getting replaced. But major problem will happen to the traffic. There will be too much traffic jam, too much pollution because of that, and those needs to be accounted also. And we do not have those detailed data, even though some people did some sort of modeling and they have projected data, but there is a need to validate those data and then refine it, and then it should go to the society so they understand also. And so, finally, when we take a decision, it should be a decision for the society. It is not only for the one contractor who took contract and then he or she is really bearing the burden. It is basically loss to the society. That is what we are trying to think from that angle. Even the medical devices, like even the needles we use, sometimes needle get corroded also for whatever reason, right, and then somebody is taking injection from that corroded needle, naturally the person will get affected. Even the implants which have in our body, if they get some sort of a corrosion, it will cause a major health issues also. So those things are important, but these numbers have not been documented across the nation. And then whatever the even the GDP 3% whatever is shown for the USA, in fact these numbers which are indirect numbers, which are causing a problem to the society, causing problem to the nature or to environment, they have not been yet well documented. So that's why the NRC say there is a need to do research in these areas, so that things will come in a better manner. So these are the all things against the corrosion. Now good things are also there. What this report also says, if we understand the corrosion, if we know how the material can be removed, then we can do a good manufacturing also, and that has exactly happens with a number of manufacturing processes. Let's take an example of semiconductor. Semiconductor device manufacturing really relies on a multiple etching. We know that removal of the material, right? Then deposition also, that oxide gets deposited on surface. How do we go ahead? Even the multiple oxidation process. So this is a what when we learn the corrosion science, and then we understand how to remove material, how to deposit the material, what are the parameters, how to fine tune particularly the nano level. As I mentioned in in this lecture earlier, one sentence, that even the natural oxide which happens on the metallic surface, that's only of the 10 nanometer level. We have been talking too much about the micron level, but 10 nanometer, if we are able to do really good job, then why do I really require three-dimensional the systems as such. So learning, understanding and upcoming with a better research will help the society in a much bigger manner. So this is what we are trying to think in that direction. I give an example of only the semiconductor industry, but you look at various material science or material synthesis, even performance analysis, even the sensors, and even the biodegradability, or even the recycling of the battery, or even the battery design, or maybe non-ferrous metals. Everywhere the science related to corrosion can be infused, and then understanding can be enhanced significantly. So what we can say in a very small, say in one sentence, we say the glancing a comprehensive understanding of the science and technology behind corrosion contributes significantly to the society in various ways. So this kind of course is very important. If we learn mechanism, we know how to really detect the faults, and how to really and think about a coating or kind of the barrier between the system and an environment, then it can really help society in a much bigger manner. Let's take the one quick slide, maybe this I'm taking reference of 2017, what they have given comparison, what happens at the developed country, what happens at the the based country, or what happens when there is no agriculture and lesser number of the services. So they have given 5, one is the United States, Japan and United Kingdom. They found in these 3 developed countries, more or less responses are fine, more or less same. Like in USA, service sector is around 79% contribution on the cost of the corrosion, while in this case Japan 73, and again United States is 79%. So they are not been talking too much about agriculture. Agriculture is only 1%, agri 1%, and in 1%. When come to the India, the agriculture corrosion cost is around 17%. Now come to the Kuwait, they don't have agriculture, they have a lot of oil industry, and then that's why the 51% failures on the corrosion cost is because of the industries. So while in case of the developed country, they can see industry 20%, in this case UK 20%, Japan 26%, and of course in our India also that is a 26%. So these are the something like this number may vary from country to country, because there are different segments, and instead of talking about one cost for 3%, 6%, 5%, we can go with the segments and then figure out which is a more critical segment and where we need to focus. That is why this paper is important from that angle. So, what we can say here, profile of United States, United Kingdom, Japan, which all three countries are known for that their advanced industrial and service economics are the similar. The pattern is more or less same. Coming to the India, India has a strong agriculture base. So, that is why the corrosion or equipment corrosion is also on a higher side, in particularly the agriculture side. Coming to Kuwait, they do not have much agriculture, but they have oil industry. So, the cost of the failures or corrosion will be on higher on that side. However, in this paper, what is not there, that is what there is a need to emphasize. We say occurrence of the missing deadline because of the some failure, and then we are not able to meet the deadline, and if it is so there will be some cost. It has not been accounted, even the mishaps not counted, forced shutdown of the industries or machine not being counted with, the various accidents which are happening because of the corrosion, they are not counted. So, this kind of costs have not been accounted appropriately. Maybe some industry are doing it, but it is not available in open document. So, there is a need of more and more data to take a right decision and then think about the corrosion, which in my view the only what we have been exposed to the 50% of the corrosion problems, or maybe the financial losses caused by corrosion is only 50%, but in reality it can be the at least 2 times. Now, with this slide I am reproducing, or maybe showing again which I started in the first lecture or maybe introductory lecture, which we say that in India we have a number of segments. We have some on the overall contribution, and we say the 6% goes to the agricultural losses, mining, manufacturing, oil and gases, water management. Everywhere corrosion is there. And then electricity, power, corrosion is almost 10%. Even the construction industry, the losses are around 3.2%. So, these are the contribution of on the corrosion cost, and that is why we mentioned there that time the overall cost is something like coming of 5.95%, but if you look at the direct cost, it is only 2.3%. Indirect cost, maybe because of the failures one way or another way, or the missing a deadline which may be counted, may not be counted, is a 3.65%. On these data we took from the references. So, the 1-star reference is here, where we try to compare cost of the corrosion is roughly around 1.67 lakh crores in this case, and then we took this is a 3-star where the reference has been showing that even for complete budget for the education in India is roughly 1.13 lakh crores, which is a lesser than the cost of the corrosion. So, that is why we require more and more education, more and more awareness related to corrosion, so that this cost can come down significantly. Now, I am again trying to take some pieces of my earlier slide question, as I say that can really we quantify corrosion? It is very difficult, but we need to do modeling, we need to really do the modeling and update using data driven approach. What was shown in earlier slide was something like what are the economic losses as a direct losses, which was mentioned around 2.3%. Indirect losses, now this has become because of shutdown. There is a efficiency loss because of corrosion, materials will some sort of cracks will be generated, or maybe some surface will be lost, there will be some sort of efficiency loss, some product loss, and sometimes we do over design also. We say, oh, we know that material will get removed or material will have some crack, so why not we take a factor of safety 2, why not we take a factor of safety 4, particularly in the big bridges. And we are doing unnecessary over design. We could use a lesser material to design those things, but we are doing over design. So, those losses are also there. Now, this is the table available from a reference, and then which indicates that there are and then the number of GD and GNP, particularly instead of GDP, they have given the percentage losses as such. You can see here in this case and then what we are able to realize that India's name is also there and Japan is also there, but in this we are able to see some different methods, so which have been utilized by the authors. And this is table 2, and this is the reference from where this table have been picked up, which was published in 2006. You see the cost of the corrosion and losses due to the corrosion, and this is what our topic is, the financial losses. Now, what are the financial losses? The loss of the production, which I already mentioned. Now, here one thing is that loss of human life is very difficult to quantify that. Then another one is that loss of the product and maybe the pipe deterioration, plant efficiency, that is what has been mentioned, and then major another one is that the damage which is causing the pollution of the environment. To some extent the government impose taxes on those companies which are really releasing it, but overall it really affect the human life one way or another way. As I earlier mentioned, that Bhopal tragedy is one of that. Another one we already mentioned about over design. We say the over design, oversizing. We do, so that we know that material is going to get damaged. Why not we take some sort of precautions, and then we do over designing maybe 2 times or maybe 1.5 times compared to that. And then as I mentioned, there are the methods. So the OLIG method is there, how method is there, and then third method is also input output method. So there are some sort of we will be discussing about these 3 methods in the present lecture, and we detail in a next lecture about this. So OLIG method is something we need to think, because it has been applied in 2001 in a publication, and it is really showing some good results. Now, if this direct and indirect cost which we have discussed, it's very difficult to take a really right decision. As I say, there is a lack of the data. So, if I think from different mind, if I want to really do some sort of anti-corrosion measures, and then we want to buy, we want to really do a coating, we want to do surface treatment, we want to really delay by using some sort of nano additives. These are the direct costs which will be simple to take a decision, and we will not have much problem. But because of this addition, because of this coating, that life of the system will enhance by 5 times. That is exactly not possible. That is why we require a data driven approach. We need to keep getting data, and then based on that we need to really get a results. Either we do a accelerated test or some other results, but estimating future maintenance event is very difficult, because there are huge number of parameters, and we really require a good science to really think about, because those things are very uncertain, and to convert to certainty only the data or maybe the knowledge and even the tested knowledge are very important to think from that point of view. Even sometime, and some references, they say the direct cost means the design cost, manufacturing cost, fabrication cost, and even the overhead charges like the management charges. While coming to indirect cost, they simply say indirect cost is something like which society is going to bear and how that can be calculated, right? And that is very important. In some cases, big contract have come up now, and we know that even in that situation party have to bear, but they do extra taxation. Maybe if you take example of the highways, and then the whole highway is on a contract for the 15 years, for 25 years, where whatever the maintenance related thing the concerned company will do, but we had to bear the cost, or society has to bear the cost also. So, this is very important to understand it, and the society has to bear cost one way or another way, and when the society is getting involved, so that is why the knowledge spread is very important to understand, and we go ahead. Even something like where there is a lawsuit, or maybe some case has happened, we have many such cases in this case, where the penalties have been put on the companies by the courts, and particularly to the help people or maybe cleaning purpose or whatever. So, in this situation also the company bears, but even the society bears in the cost in that manner. So, whatever the damage, if you want a lesser damage in the future, so effective utilization of corrosion engineering is very important, and that is what we want to emphasize again and again. When we have a knowledge, then only we can really think about the policies, we can really think about taking effective measures. As I mentioned about the traffic delay, now how company can really bear the cost? Traffic delay, somebody is getting late and then the cost goes to him or maybe her. These are the important aspects where we need to really think and then come up with some good models, and that is why the NRC says that there is a lot of research need in this kind of areas. So, this is what we really need to think for the future. Now, coming to the three models which I showed in my previous slide, you say that three methods to quantify corrosion is the Oleg method, as I mentioned, how method, and then method of input and output, where we really required a lot of data. Now, Oleg method is say something, it calculates the corrosion cost depending on the preventive measures which we are taking, or some sort of a strategy we are trying to take, whatever the cost for that. So, again indirect cost will not be accounted in this case. So, in this case the focus is basically estimating cost of the corrosion prevention technique. It was of course they try to distinguish between indirect and the direct the cost, indirect and indirect costs, or maybe the corrosion expenditures. And then they mention very clearly owners and operator incur direct costs for the corrosion avoidance, maybe when they are thinking about the coating, when they are thinking about corrosion resistant materials, or maybe some sort of cathode protection. While this is coming to the indirect cost directly to the users. Now, some damage happened in your systems, then it is basically you need to bear it, or maybe the customer or user need to bear it. So, mostly indirect cost is related to that in the bearing by the society itself. While in case of the home approach, they have a thought over the impact, economic impact. What will be the, because of the some sort of the failure has happened, what will be the impact on the others also, and then they try to really do by, instead of going for the complete system, what will be the individual characteristics and then individual requirement particularly for various sectors. So, these things were accounted in this method, in slightly better method. While coming to the input and output, there are so many parameters which we need to tabulate and then come up with this approach. So, naturally this input output math approach will be exhaustive approach, but we really require many data for that purpose. Unfortunately, even though we know that there are huge economic losses, but we do not have any concrete approach to go ahead with good assessment related to the cost. The only thing is that we try to mitigate, understand and mitigate those losses and as far as possible. So, educated decisions require knowledge, right, and then somebody can say 5%, somebody can say 4.5%, somebody can say 6% based on the cost which they are considering. There will be some sort of subjectivity. Even in that situation, today there is a subjectivity. If we keep getting a data and we can refine those models. So, even in initial level we have a rough data, maybe some models available, and then we take the decision now itself. So, that is why this lecture is important. Even though suppose we do not have a concrete method to analyze, but we know the number of factors which are really related to corrosion. So, can we really think about that, and then the effect, or maybe say minimize economic and societal effect of the corrosion, and that will be the really our achievement, will be the right direction. Now, there are number of methods also, but I mentioned 3 methods, but there are some sort of method available from management point of view, and then when we say the corrosion management financial tools. So, what is the cost of the corrosion, which we have been discussing already there, and then these as I mentioned, these are the tools which are assisting to the societies or industries. This method nowhere is connected with the society as such. These are the methods related to industry, how industry can reduce the cost, enhance the life. Indirectly, to some extent it will help society, but there is no direct relation. There is another method what we call a life cycle cost analysis. To some extent we have covered it, ROI kind of thing, the returns on investment, cost benefit analysis can be done. Now, we will be covering a bit of this. We say life cycle cost analysis, we can think about some sort of initial cost whether we are buying something, then there is operational cost, there is a maintenance cost to refine, and then there will be finally disposal cost. This is tricky, disposal cost, reason being some places when we want to discard the final machine, we need to pay money also. So, in that situation this positive sign will, a plus sign will make sense. However, sometime we get, when we dispose of some material or maybe like our car, we get some money back. So, in that situation this disposal cost will be minus sign, that means it needs to be reduced. However, the life cycle cost, we know that when we are investing money today and then operation cost may be today as well as next year also, and then we know there is always some sort of inflation or there will be some sort of interest rate that need to be accounted, and those things really come in this form. When we say the net present value, we need to think about what are the future benefits and future cost, and that will give the net present value, and based on that we can take some decision. And then sometimes we really require benefit cost ratio. So, we say that future benefit, future cost need to be brought to the present system, and then we can take a decision based on that. And so, indirectly what I am trying to convey is that we can take a number of corrosive resistance measures, but question comes whether those measures will be really useful, whether really give us some sort of enhancement in a performance or enhancement or maybe the making a better environment for society. If these are not quantified properly, then decision making will be very difficult. To quantify this number and then take a decision, and then that decision will be sound. It may not be 100% correct, but decision will be sound. As I mentioned that we can go ahead with data driven approach, we keep refining. Today we are getting some decision and we are getting some sort of efficiency or the benefit to cost ratio some level. Tomorrow we will be getting better because we will have a better data, or maybe if we get slightly lesser, at least we will know, we will be able to pinpoint what is the problem and where we need to address and how do we address that problem. So, these are the important thing to understand, or if I again try to reframe my sentences, we say we have done the corrosion cost analysis in this course. What we do basically, we take all the measures, and then we know very well in some sort of organization some machines are getting failed and they are buying new machine, or maybe they have bought initial machine and then they are doing some measures on that. So, cost will be available, the data will be available. So, corrosion cost analysis will not be that difficult. Coming to the life cycle cost analysis, in this situation also we are going to analyze whole life cycle, that what is the procurement cost, or what kind of maintenance, what is the operation cost, and what is the disposal cost also. So, those things are there. Now, somebody says no, I will go ahead with ROI analysis. So, where I had to take a decision, whatever the life cycle cost which is giving to us, will that be beneficial, shall I invest money or I should not invest money. So, that comes with the ROI, and that is a management tool, people utilize it. Coming to the cost benefit analysis, we take a present value, maybe the future and there is a maintenance cost and there will be dispose of cost, and we need to take in present time that cost and then take a decision based on that. Another one what related to management comes is something like risk assessment, and in this risk assessment is something like a probability. We need to figure out what is the probability of failure or probability of success also. So, those things are important. And another approach was something like maintenance planning and optimization. Even though I try to maintain my system very good, nice, but returns are not that much, naturally the investment in that side will not be good, and that is why we really required a complete comprehensive approach to go ahead with a good decision related to this. So, understand what I said. Let us take one example. We say in this case we are trying to figure out life cycle cost analysis, LCCA, and what is given to us is something that the formula which I described in previous slide. What is acquisition cost or input cost, and then operational cost, maintenance cost and disposal cost. As I mentioned, the disposal cost can be positive, can be negative also. We may get money or we may need to pay money to somebody so that the disposal of the machine happens. Now, coming to the cost side, we can figure out, and then if you are trying to keep all the costs in present value, then we need to think about inflation. And what is inflation? Whether in this case we are taking inflation or maybe the rate of interest around 8%. So, in this case R will be 0.08. So, what are the costs which are being given to us is the cost of initial cost is suppose 12,000, it can be rupees, it can be dollars. Now, recurring cost is something like a maintenance, repair and gas consumption, something is coming around 1000 for maintenance, and the gas is something 3500. So, 4500. Now, finally, discarding cost or maybe disposal cost is something like a 3000. So, when you discard, provided we are assuming that life is a 5 years. Right. So, we can estimate what will be the overall cost or we say that the life cycle cost analysis from this point of view, and we can use a small would say that algorithm or maybe MATLAB program. So, here we have written AC 12,000, RC if you have 4,500, RV 3,000, and then the total duration of the system is the phi, and interest rate has been given around 8%. So, we will take value from that point of view. So, interest rate divided by 100, it will turn out to be the R value is a 0.08. Now, we even though the cost of the maintenance has been fixed something like a 4,500, but we need to count everything in today's time and the present value. Naturally, we need to write that in this form. So, in this case a PV what has been mentioned, we are taking this PV factor as a 1 divided by 1 plus R on the power 5. So, that is in this case because of we are talking of the 5 years, that value comes something like in the starting that because this is the end of this cost. Whole cost we are talking about today, and what will be the end of the year, that has been mentioned 0.92, 0.85, and slowly it is coming down. While in the summation point of view, recurring overall in 5 years we are paying roughly 17,967. So, it is a much lesser, because if I talk something like a 4,500 into 5,000 5 times, then naturally this cost will be on a higher side, roughly coming at 22,500, but in actual case, in present case, we are taking something like a 17,967, which is a lesser. Coming to the residual values, which is a 3,000, and present value in this situation will be roughly 2041.7, a round off something like a 2042, that will come out. So, this is what we are trying to calculate all the cost in a present scenario, and overall sum will something will come out to be 27,925 for the 5 years life. Now, this is a life cycle cost analysis what we are getting. If we know how many benefits we are getting from this device, that can be quantified, then we will say whether there is a benefit to the cost ratio is a higher side or not, or maybe we should invest or not. So, this is giving finally how much really we are going to invest in the whatever the machine, in the car, or maybe whatever the equipment we are buying. So, this is the in present value the cost from that angle. Now, another one which we had talking something like in this case we are now in this case we are taking rate of interest something like a 6% instead of 8% in previous case, and then we are talking something like the cost, initial cost, then benefit, then 3,000 this one, and finally we are trying to figure out what is the benefit to the way last time we say what is the cost. Now, here we are also taking some sort of benefits also. So, benefits we are dividing into the per year benefit. So, this is the initial cost, maybe say 100,000, the benefit is coming in 50,000 per year, or maybe the first year, then 30,000 in second year and 60,000 in the third year. So, this is we are trying to calculate based on 3 years are we really fine, are we going to get a benefit in this form or not. So, this is what has been done. As I mentioned, in here we are taking R value as a 0.06 as a 6% overall, and we are counting based on this, and then what this comes out to be something like starting from a 0th year in today's itself. So, 1, 0.47, then 0.2, and then in this case factors are changing, and what we are getting overall benefit to the cost ratio is something like 1.24. So, it is a kind of advantages, and we can go ahead with this number as such. However, there will be some sort of the point coming that in between the number second year when we are tabulating it, why at the end of second year we have a benefit of only 30,000. Now, why not we have 50,000, why not we have 60,000. So, when we tabulate the numbers, when we compare it, then there is also the chance that we can improve the system also, and then we can, maybe if there is some flaw, then we can improve that also. So, those things are important to consider when we are documenting, when we are using these formulas and some sort of calculation. It really hints to the the direction where we think, and then overall increase the benefits for us. Now, we think from this is another slide which I already present in my one of the lecture, where we are talking about economic analysis or basically controlling the surface degradation or minimizing surface degradation. That time also I mentioned that taking decision to allocate the fund is the important thing, and that requires a knowledge of the surface degradation. And then in this situation, what we say that what is the cost and what is the saving, and then saving we need to also think from annuity point of view, or maybe accounting the interest into this. So, that also mentioned that if this overall cost is decreasing, suppose number of years, and the interest rate is increasing, then what will happen? We need to really recover whole amount in much lesser number of years. If it is not, then it is not really right decision to invest money, it will be bad decision. So, that was mentioned here in this case 10 year, but interest rate was only 0.05. In the situation the overall annuity was around 7.72, while coming to the 10% we calculated 6.14. This is the same slide which I had given earlier lecture, but I am trying to connect with the present lecture. And we say here also in this situation, if this green line goes on the negative side, there is no point, this will be unprofitable to go ahead with the surface the controlling surface degradation. There is no point to go ahead with the surface degradation. Of course, if we are talking about the society, and then we are able to bring the socio-economic effect which I mentioned in IPCC, we can really figure out those socio-economic effects. If we consider that, quite possible we may take a decision, yeah, this controlling surface damage degradation will be important, and we need to go ahead for the society. But if we think from only industry point of view, we may take a decision, no, for industry this is not important because it is not going to give any profit to us. However, this is where we require policies when everybody has a knowledge, and then we know that this system which is they are not taking appropriate measures, and then it is really costing the society. So, those things are important. While in this case what we mention about the saving, if we are not taking any measures to avoid the surface degradation, what is the probability of failure, and then what is the probability of success or probability of failure if we are taking surface degradation methods to minimize the surface degradation. So, if this probability naturally without measures will be naturally on a higher side, so this probability will be suppose 0.2, 0.3, 0.4, and this probability when we take in the measures will be lesser. So, this term will always be positive, and then cost of the failure will be there. It can be the per failure, per year, or per month, whatever, and that will give us some sort of saving, and that saving can be fitted in this. We know the initial cost, we know that what is the number of years and the life of the system, what is an interest rate or return of the rate, whatever we are assuming. In this case we assume the interest rate, instead of interest rate, what will be the return rate. if I am thinking about a much higher rate from machine, there is a 15% return or 10% return or 5% return. So, that in the situation it will be useful. So, in this case annuity rate was basically we are expecting a higher return, and sometime we say that the big businesses or maybe the business who want immediately returns, they may fail to launch a product or a system in a society. Now, this is what again as on the repetition of a slide, what we say the probabilistic analysis of controlling surface degradation. This is the same formula which we have written, and then we say that in this case the cost on the cost F is the expense of failing, and then we took some sort of example also to clarify it. We say assume likelihood of the failure, the probability of the failure in absence of any preventive measures. So, P here is a P the preventive measures, and then this is a no preventive measure or without preventive says. So, that is why we say probability of no preventive is 0.3, probability of preventive measure is something like a 0.1, and then failure cost which will occur will cost something like 100,000. Now, that is where we say 0.3 minus 0.1 into 100,000, this comes to something like a 20,000. So, if we take measures and then the benefit comes around 20,000, naturally we need to talk what is the initial cost and then what is the rate of returns we want from that, and then when you feed this data, overall results will be more favorable. However, we are saying here the estimating rate of the material degradation is challenging because there is a little information provided to help whether we should take these measures or not. Investment subject of the material degradation, maybe we say that people may not have that kind of interest if a rate of returns expected rate of returns on the higher side, as I showed in previous slide, that if we have a rate of returns around 15%, we may say no to the new method to avoid the surface degradation. However, if it is a 5% expected returns, then we may say yes, and that is why the many times, as I mentioned in previous lecture also in the earlier lecture, that if you are taking some sort of risky project, the government gives initial grant fund, so that success can be really established. We know that the businessman or business point of view, high returns will be expected, but if there is a subsidy, if there is some sort of government funding available, then we may expect a lesser return also will be fine for us. So, this is a very important, and with again the decision making or policy making is depending on this. Now, coming to the what kind of methodology we should really follow to think about a corrosion cost or minimizing the corrosion cost. We see as I showed in one of the slide, that various countries they will have a different sectors, and which is causing a more corrosion cost and which is causing a lesser corrosion cost. So, we should assign the sectors, and even in sectors what are the subsector which are more prone to the corrosion. If you are able to study those things, that will be very good. Another as we say that most of the reports, annual reports or IPCC reports, they are available. We go through that, maybe either through the software or maybe directly read, and then we incorporate those things there. Now, we also learn something like experts. I do research for the 20 years, naturally I will have a lot of hidden knowledge in me. We have not documented everything on a paper, that is what we call a tacit knowledge, and that is why the interviews of experts will really help to extract that knowledge. So, this is the first identification of sector or subsector, identification of the experts from industry, from agencies or authorities, those data. So, if we have those data, this data from this side and this data from established literature, we need to do a processing and analysis of data. Based on analysis of all the data, we need to really come up with some sort of a corrosion cost estimation. And subsequent to that, we also will know that what will be the effect of those corrosion on a society. So, that is why we say the impact on national economy also will be there. Now, for that purpose we need to think about the diffusion of a knowledge, awareness of the knowledge to the society, and then think about various anti corrosion policies. So, overall is the first the estimation of the cost, and then whatever the corrosion related data we have, a corrosion mechanism data we have, think about the national economy, effect of the national economy, and then once we have those things, giving awareness to the society, giving and then proposal related to the anti corrosion policies, and then spreading those data so that people can really take a right decision. We know the water is really corroding, or maybe humidity is also corroding, some chemicals are corroding. So, we should not keep them in the open, so which will really react with the materials. So, those things are important to understand. If I see from a bigger perspective, what we say economic analysis of corrosion is a comprehensive procedure that encompasses cost of the corrosion in many economic sectors. So, we really need to figure out which sector is really affected severely. We need to take measures from that angle. Now, we say that we need to think about the collecting data, as I mentioned, the collecting data from experts who have spent a number of years in those areas, and that is what we call a tacit knowledge that remains only in their mind, and many times we are not able to document. So, can we really collect that data, and those things will become we can call as something like expert input, and in management this is one of the common tool people utilize. And the data collection from literature is very important. It will really help us in a big way. Then we come to something like a data processing and an analysis. We say after collecting data, we must be processing data in a manner so that we can figure out separate patterns. That is what we have learned in data driven approach, that we should uncover the pattern, we should figure out what are the correlation, what are the trends, and then based on that we propose some sort of models, and then those models also should come up with a continuous updation. That is why data driven approach is very important. And when we do all this, we say that we will be able to really refine and then be able to project, and then wherever there are research gaps, that also can be pinpointed easily from that point of view. Now, another thing, as I say, that once we have all the data available, and then their impact on national economy must be assessed directly or indirectly, whether people have a knowledge. If people have a knowledge, it will really enhance much significantly manner. Maybe we have not reached to the some area, while when the common public is getting aware of those data and the knowledge, naturally they will be involved in that. What will happen in the situation? There will be economic growth, there will be employment, there will be good competitiveness. So, this is overall required. We require economic growth, we require employment, we require competitiveness for the overall society development. So, that will happen with this kind of measures. Another thing which we say, the anti-corrosion policies, if some companies are not really working from society point of view, they are looking only from their own benefit point of view. In the situation, at least if we have a knowledge about anti-corrosion policies, or we are proposing to the concerned authorities, and those are implemented, then we will be able to figure out which and then the company is not really sticking to those policies, and then we can really mend them, educate them, so that they can get aligned to the society welfare. And then as I mentioned, the data fusion is important, because people should know, a stakeholder who are one way or another way connected, they should be knowing about all those data, all the complete science, because most of the times there is a lack of knowledge, and that creates a lot of confusion, that creates a lot of misunderstanding. If we have a good knowledge, and then the society can be made in a much better form. So, these things are very important for us, and I believe if we are able to do that, that will be overall very good for society. Now, coming to the what are the challenges which we mentioned about the National Research Council in 2011 mentioned. They say corrosion research grant challenges and possible solution should be addressed. And then we already have learned something like understanding corrosion mechanism, prevention mechanism, or even the selection which method will be good, continuous monitoring, environmental challenges, modeling and prediction, education and workplace development. So, these are the things which we have covered to some extent in this course, and I am hoping that you will be really doing good advanced research in this area in the future, or maybe we will take some courses in this area which really helps you in a bigger way. If I try to convey in slightly different manner, what we say, the corrosion grant challenges are the serious concerns, and then whatever the obstacle related to corrosion which we are not able to think immediately need to be addressed maybe through research collaboration. When we talk about research collaboration, academic institutions, they do research, but they need to also collaborate with the industry. And then another, like I am from mechanical engineering. Now, if I want to go at the collaboration, I should collaborate with the material scientists, one chemistry, engineering, other disciplines one way another which are really getting involved. So, that kind of collaboration is very important, and as I say, the partnership with the industry is important. So, in a holistic manner only the development can happen. And what we have already studied in this present course, we say corrosion mechanisms were described in the present course, information on mechanisms related to the localized corrosion, galvanic corrosion, stress corrosion, corrosion cracking, even the corrosion under extreme condition like a high temperature, chemicals environment, even the radiation environment, material degradation mechanism, environmental impact on those kind of degradation have been already informed this course. And then we also mentioned something like a corrosive resistant material, coating selection, even we talk about the inhibitors which can really minimize the corrosion rate, that can be and then the data can be collected and can be utilized in a better manner. We have given some sort of coverage on the data driven approach, that we say that initially assume some sort of model or maybe the train, and then with that by getting continuous data, that should be refined in a bigger manner. We also discussed something like a life cycle assessment, and then based on that, if we are trying to enhance the life of the component by maybe say some years, and whatever the mitigation approaches we really require, corrosion mitigation approach, what will be the cost of those mitigation and what will be the benefit of overall increasing, enhancing the life cycle of the system, that should be accounted. Based on that, we can think slightly on maybe we talk about the MATLAB coding also. We say the computational modeling and then predictive tools using a kind of machine learning, artificial intelligence, very critical for the future, and those things should be accounted in a proper way. So, these are the important things for us, and thank you for attending this lecture. Thank you.